This lecture is a summary of this whole course. First, let's revisit the topics that we covered in this course. In the beginning, we talked about the natural language processing and how it can enrich text representation. We then talked about how to mine knowledge about the language, natural language used to express what's observed in the world in text data. And in particular, we talked about how to mine word associations. We then talked about how to analyze topics in text, how to discover topics and analyze them. This can be regarded as knowledge about the observed world. And then we talked about how to mine knowledge about the observer, and particularly talked about how to mine opinions and do sentiment analysis. And finally, we talked about the text-based prediction, which has to do with predicting values of other real-world variables based on text data. And in discussing this, we also discussed the role of non-text data, which can contribute additional predictors for the prediction problem. And also, it can provide a context for analyzing text data. And in particular, we talked about how to use context to analyze topics. So here are the key high-level takeaway messages from this course. I'm going to go over each of these major topics and point out what are the key takeaway messages that you should remember. First, in NLP and the text representation, you should realize that NLP is always very important for any text applications because it enriches text representation. The more NLP, the better text representation we can have. And this further enables more accurate knowledge discovery to discover deeper knowledge buried in text. However, the current state of the art of natural language processing is still not robust enough. And so as a result, the robust text mining technologies today tend to be based on word representation and tend to rely a lot on statistical analysis, as we've discussed in this course. And you may recall we've mostly used word-based representations, and we've relied a lot on statistical techniques and statistical learning techniques particularly. In word association mining and analysis, the important points are, first, we introduced two concepts for two basic and complementary relations of words: paradigmatic and syntagmatic relations. These are actually very general relations between elements in any sequences. If you take it as meaning elements that occur in similar context in the sequence and elements that tend to co-occur with each other, and these relations might also be meaningful for other sequences of data. We also talked a lot about the text similarity. When we discuss how to discover paradigmatic relations, we compare the context of words to discover words that share similar context. At that point, we talked about representing text data with a vector space model, and we talked about some retrieval techniques such as BM25 for measuring similarity of text and for assigning weights to terms, TF, IDF, weighting, etc. And this part is well connected to text retrieval. There are other techniques that can be relevant here also. The next point is about co-occurrence analysis of text, and we introduced some information theory concepts such as entropy, conditional entropy, and mutual information. These are not only very useful for measuring the co-occurrences of words, and they're also very useful for analyzing other kind of data, and they're useful for example, for feature selection in text categorization as well. So this is another important concept to know. And then we talked about the topic mining and analysis, and that's where we introduced the probabilistic topic model. We spent a lot of time to explain the basic topic model, PLSA, in detail. And this is also the basis for understanding LDA, which is theoretically more opinion model, but we did not have enough time to really go in depth in introducing LDA. But in practice, PLSA seems as effective as LDA, and it's simpler to implement. It's also more efficient. In this part, we also introduce some general concepts that would be useful to know. One is generative model, and this is a general method for modeling text data and modeling other kinds of data as well. And we talked about the maximum likelihood estimator and the EM algorithm for solving the problem of computing maximum likelihood estimator. So these are all general techniques that tend to be very useful in other scenarios as well. Then we talked about text clustering and text categorization. Those are two important building blocks in any text mining application systems. In text clustering, we talked about how we can solve the problem by using a slightly different mixture model than the probabilistic topic model. And we then also briefly reviewed some similarity-based approaches to text clustering. In categorization, we also talked about the two kinds of approaches. One is generative classifiers. They rely on Bayes' rule to infer the conditional probability of a category given text data. In particular, we introduced the naive Bayes in detail. This is a practically useful technique for a lot of text categorization tasks. We also briefly introduced some discriminative classifiers, particularly logistical regression, k-nearest neighbor, and SVM. They are also very important. They are very popular, and they are very useful for text categorization as well. In both parts, we also discussed how to evaluate the results. And evaluation is quite important because if the measures that you use don't really reflect the utility of the method, then it would give you misleading results. So it's very important to get evaluation right. And we talked about evaluation of categorization in detail with a lot of specific measures. Then we talked about the sentiment analysis and opinion mining. And that's where we introduced the sentiment classification problem. And although it's a special case of text categorization, but we talked about how to extend or improve the text categorization method by using more sophisticated features that would be needed for sentiment analysis. We did a review of some commonly used complex features for text analysis. And then we also talked about how to capture the order of these categories in sentiment classification. And in particular, we introduced the ordinal logistical regression. Then we also talk about the latent aspect rating analysis. This is an unsupervised way of using a generative model to understand the review data in more detail. In particular, it allows us to understand the decomposed ratings of a reviewer on different aspects of a topic. So given text reviews with overall ratings, the method would allow us to infer the ratings on different aspects. And it also allows us to infer the reviewers' latent weights on these aspects. Which aspects are more important to the reviewer can be reviewed as well, and this enables a lot of interesting applications. Finally, in the discussion of text-based prediction, we mainly talked about the joint mining of text and non-text data, as they are both very important for prediction. We particularly talked about how text data can help non-text data and vice versa. In the case of using non-text data to help text data analysis, we talked about the contextual text mining. We introduced the contextual PLSA as a generalization or generalized model of PLSA to allow us to incorporate the context variables such as time and location. And this is a general way to allow us to review a lot of interesting topical patterns in text data. We also introduced the net PLSA. In this case, we use social network or network in general of text data to help analyzing topics. And finally, we talked about how time series data can be used as context to mine potentially causal topics in text data. Now, in the other way of using text to help interpreting patterns discovered from non-text data, we did not really discuss anything in detail, but just provide a reference. But I should stress that that's actually a very important direction to know about if you want to build a practical text mining systems, because understanding and interpreting patterns is quite important. So this is a summary of the key takeaway messages, and I hope these would be very useful to you for building any text mining applications or doing further study of these algorithms. And this should provide a good basis for you to read frontier research papers to know more about more advanced algorithms, or to invent new algorithms yourself. So to know more about this topic, I would suggest you to look into other areas in more depth. And during this short period of time of this course, we could only touch the basic concepts, basic principles of text mining. And we emphasize the coverage of practically useful algorithms. And this is at the cost of covering some more advanced algorithms only briefly, or in many cases we omit the discussion of a lot of advanced algorithms. So to learn more about this subject, you should definitely learn more about the natural language processing, because this is the foundation for all text-based applications. The more NLP you can do, the better representation of text you can get, and then the deeper knowledge you can discover. So this is very important. The second area that you should look into is statistical machine learning. And these techniques are now the backbone techniques for not just text analysis applications, but also for NLP. A lot of NLP techniques are nowadays actually based on supervised machine learning. So they are very important because they are key to also understanding some advanced NLP techniques. And naturally, they will provide more tools for doing text analysis in general. Now, a particularly interesting area called deep learning has attracted a lot of attention recently. It has also shown promise in many application areas, especially in speech and vision. And now it has been applied to text data as well. So, for example, recently there has been work on using deep learning to do sentiment analysis to achieve better accuracy. And so that's one example of advanced techniques that we weren't able to cover, but that's also very important. And the other area that has emerged in statistical learning is the word embedding technique, where they can learn a vector representation of words. And then these vector representations would allow you to compute the similarity of words. As you can see, this provides directly a way to discover potentially paradigmatic relations of words. And the results that people have got so far are very impressive. That's another promising technique that we did not have time to touch. But of course, whether these new techniques would lead to practical useful techniques that work much better than the current technologies is still an open question that has to be examined. And no serious evaluation has been done yet in, for example, examining the practical value of word embedding other than word similarity based evaluation. But nevertheless, these are advanced techniques that surely will make impact in text mining in the future. So it's very important to know more about these. Statistical learning is also key to predictive modeling, and which is very crucial for many big data applications. And we did not talk about that predictive modeling component, but this is mostly about the regression or categorization techniques. And this is another reason why statistical learning is important. We also suggested you to learn more about data mining, and that's simply because general data mining algorithms can always be applied to text data, which can be regarded as a special case of the general data. So there are many applications of data mining techniques. In particular, for example, pattern discovery would be very useful to generate interesting features for text analysis. And recently, information network mining techniques can also be used to analyze text information network. So these are all good to know in order to develop effective text analysis techniques. And finally, we also recommend you to learn more about the text retrieval, information retrieval, or search engines. And this is especially important if you're interested in building practical text data application systems. And a search engine would be an essential system component in any text-based applications. And that's because text data are created for humans to consume. So humans are at the best position to understand text data. It's important to have human in the loop in any big text data applications. So it can, in particular, help text mining systems in two ways. One is to effectively reduce the data size from a large collection to a small collection with the most relevant text data that only matter for the particular application. Right? So the other is to provide a way to annotate, to explain patterns. And this has to do with knowledge provenance. Once we discover some knowledge, we have to figure out whether the discovery is really reliable. And so we need to go back to the original text data, verify that. And that's when the search engine is very important. Moreover, some techniques in information retrieval, for example, BM25, vector space, and language models, are also very useful for text data mining. We only mentioned some of them, but if you know more about the text retrieval, you'll see that there are many techniques that are useful. Another technique that's useful is the indexing technique that enables quick response of a search engine to a user's query. And such techniques can be very useful for building efficient text mining systems as well. So finally, I want to remind you of this big picture for harnessing big text data that I showed you at the very beginning of the semester. Right? So in general, to build a big text data application system, we need two kinds of techniques, text retrieval and text mining. And text retrieval, as I explained, is to help convert big text data into a small amount of most relevant data for a particular problem, and can also help providing knowledge provenance, help interpreting patterns later. Text mining has to do with further analyzing the relevant data to discover the actionable knowledge that can be directly used for decision-making or many other tasks. So this course covered text mining, and there's a companion course called text retrieval and search engines that covers text retrieval. If you haven't taken that course, it will be useful for you to take it, especially if you are interested in building a text application system. And taking both courses would give you a complete set of practical skills for building such a system. So in the very end, I just would like to thank you for taking this course. I hope you have learned useful knowledge and skills in text mining and analytics. As you see from our discussions, there are a lot of application opportunities for this kind of techniques, and there are also a lot of open challenges. So I hope you can use what you have learned to build a lot of useful applications to benefit the society, and to also join the research community to discover new techniques for text mining and analytics. Thank you.